The purpose of this video is to review the concept of formal charge. We've had some questions about this in class, and I wanted to go through a couple of problems that we did in class together. Let's look at carbon dioxide. So before we start calculating the formal charge, we have to understand what structure it will be, and so we will create a Lewis dot structure. So let's look at the number of electrons. Carbon will get us 4. Each oxygen will bring 6. So that is 6 times 2. So we will have a total of 16 electrons. So now if we look at carbon dioxide, let's try to draw a Lewis dot structure. And if we kind of start doing this, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'll see we have a couple of problems. We don't have enough electrons to create stable octets for all of the atoms, and so we can start moving around some of the electrons. Let's move these here. Let's move these here. And so we end up with the structure for carbon dioxide, which we have been using most commonly in class, and that is the double bond. Now, another resonance structure that we could have would incorporate a triple bond, and it would look something like this. And these are the ones that we looked at in class. And so we talked about calculating the formal charge. This is a way of keeping track of the electrical charges within a molecules. And it helps us decide which is the best structure when we have a resonance structure. And we said that formal charge equals the number of valence electrons minus non-bonding electrons minus 1/2 bonding electrons. So let's look at this for these different structures. We'll have valence, non-bonding, and 1/2 bonding. Oxygen. We know if we look at the periodic table, oxygen has 6 valence electrons. This oxygen here will have 1, 2, 3, 4. That will be 4 non-bonding electrons. And then 1/2 the number of bonding electrons. So we have 1, 2, 3, 4 times 1/2 is 2. Remember, we're going to subtract these. This is a minus and this is a minus. So it's a minus and a minus. And we end up with 0. So that oxygen has a formal charge of 0. Let's look at the carbon. Carbon, valence electrons 4. Non-bonding electrons, there's 0. If we do 1/2 of bonding, we'll have 1, 2, 3, 4, 5, 6, 7, 8 times 1/2 will be 4. And we end up with 0. This oxygen looks exactly like this one here. Okay, it's the same. So it'll be a 6 minus 4 minus 4 minus 2, 0. So the formal charge on every one of these will be 0, which makes sense. There is no charge on carbon dioxide. There's no charge. It's neutral. And that is the formal charge for everything, for each one of the elements in this molecule. Now, let's look at this other structure. The number of valence electrons for oxygen is 6. Now here's where things are going to look a little bit different. The number of non-bonding electrons are 6. And then 1/2 of the bonding will be 1. These are subtractions. So we end up with a minus 1. Carbon, 4 valence electrons. Non-bonding electrons, 0 again. And here 1/2 number of bonding electrons, 1, 2, 3, 4, 5, 6, 7, 8, times a half is 4. That's a subtraction, 0. Oxygen, 6 valence electrons. Non-bonding electrons, look at them here, we have 2. And then 1/2 of the bonding electrons will be 1, 2, 3, 4, 5, 6 times a half will be 3 minus 3. And our total is a +1. So the formal charge here, oxygen will have a -1, oxygen here will have a +1. Overall, it'll be 0, and there is no charge, so that's good. But remember, one of our rules, we said when we're doing resonance, we want to minimize the number of charges, minimize charges, and we want to put the charge on the most electronegative. And here it's simple. We're going to go with this structure here because it minimizes our charges. There are no charges.